Hi, everybody. So I'll just do a quick introduction, first of all, for those of you that don't know who I am. My name's Adam Turnbull. I've been with Push for the last 10 years. My background's engineering, and I started at Push in engineering. For the last 4 years, I've been working in pre-sales. So, but the important thing about me is I like to build stuff. And this is one of those things that I've built. So the agenda for the webinar is going to be, first of all, I'll talk about what game clocks are, why we need them, a little bit about the different types of clocks that different sports use. And then we'll look at a simple but inefficient approach to building an online game clock. And then we'll move on to a more efficient way to build that clock again. And then I'd like to demonstrate it to you. So I'll show it actually working. And then I'll put up some notes about the implementation and some links to all the source code for what you can see. And then we'll have a little bit of time at the end, I hope, for any questions that you've got, which you can submit through either the online chat or if you want to email me afterwards, there'll be another link to my email address at the end. So what is a game clock? So apologies to any Aldershot supporters in here. Every sporting event has some concept of tracking time. This could be as simple as the start time and the end time, or it might be the start time and the elapsed time until such time that event's over. In the real world, there's usually a large clock for the stadium, the court, on the course, wherever, to provide information to the participants, the officials, and the audience. Now, in the world of online gaming, we're not generally able to see the stadium clock, so we have a proxy representation of it on a web page or an app to provide the same information to the audience. Having a good real-time clock that accurately reflects the official event timekeeping helps to foster a sense of involvement, as well as basic information. You don't want to find that the clock is far behind the actual event when, for example, you're following progress on TV. An end user should realistically expect the clocks across multiple devices to all be synchronized. But there are some technical challenges in keeping them closely synchronized. Now, first of all, if you think the absolute system time on the user's device could be significantly different to the actual time. Even on desktop computers, it's common to see clocks offset by several seconds or even minutes. And while there are solutions to help with this, say the NTP protocol, you've got no way to guarantee what time the user sees, and every user can have a different understanding of the actual time. There might also be in a different time zone, which would throw the timings out by an hour or more. So we can't really rely on local system time. Now, we'll take football as a simple example here. Most sports, and football is one of these, we don't need the real time at all. We don't, or what we call the wall clock time. We only really need to know the time that's elapsed since the event started. In football, we can say that a football match has got 2 halves, each is 45 minutes. And as an observer, the critical information that you need is which half we're playing in and the time elapsed since kickoff. But this is a bit of a simplistic approach, and we'll address some of the differences between this and the real world later in the webinar. Now, a bit more of a complex example is basketball. Actually, several of the American sports, because for a start, they've got more than 2 periods, and they don't just have halves. You have 3 periods or 2 periods or 4 periods, depending on, you're gonna have 9 innings. In basketball as well, clocks count down, they don't count up like they do in football. Another significant difference is the clock will stop and it'll restart regularly. It'll pause the countdown until the end of the, it'll pause the countdown, and the countdown keeps going until the end of the period or the match. And in addition to that, basketball actually has 2 clocks. It's got the main game clock and it's got a shot clock. Right, so a simple solution, and it's really to provide the end user with the current game time and other clock information by sending them a message every second. Okay. So example, you get a per second clock update from your game data supplier. Now you could pass those on as they happen easily enough through Diffusion topics. And while it has simplicity on its side, I see this being done on more than one site. It's very inefficient. We're sending far more information than is necessary. Now, a small message to set the time, whether it's real or elapsed, might be about 30 bytes, which seems to be about the average from what I've seen. It could be in JSON, it could be some other encoding. That's not really important. But over the course of a football match, that's nearly 5,500 messages, which is something like 1.5 gigabytes per 10,000 subscribers, and that's just clock information. Sometimes you'll even see the clock resolution drop down to every 5 or 10 seconds to reduce that bandwidth usage, but that kind of hurts the feeling of the involvement in the event, and it feels a bit disconnected. Now, rather than sending per second updates, we could instead consider the operations that are performed on a clock. So, ladies and gentlemen, I give you the Daktronics All Sport 5500. Right. So this is a professional multi-sport scoreboard driver. It allows events to manage all kinds of details of scoring, including the timing aspects. Actually, we're not really concerned with this piece of hardware for our use case, but you can note that it has a couple of really big colorful buttons for driving the event clock and the bottom right-hand corner, start and stop. And we're going to take those as the two basic operations that we're going to apply to our own clocks. I'm also going to include another operation, which is end period, which is a variation on stop, as it'll be useful to make this distinction later on. So with these basic operations defined, we're freeing ourselves from sending per second updates or worse than per second updates. And it will allow the client to track the time, but based on some checkpoints. So that is, whenever we send these clock state changes, either start or stop, we're also going to supply enough information for the client to synchronize their view of the time with the local state on the server. And in fact, with just 4 messages, we could conceivably cover all the actions that are required for a standard football match, which is quite a saving on the 5,500 in the simple implementation. So it's going to be a little bit more effort required to make this work, rather than just the basic pumping data, pumping the time data from the server. But I hope I'll be able to show you that it's actually fairly simple, and the logic can be encapsulated in just a few lines of configuration and a little bit of code. What we don't want to have is a completely different implementation of our clocks for every possible sport, because that just increases complexity and maintenance. Instead, we're aiming for a single model that can represent most, if not all, sporting events. There are some common themes for events. They're typically broken down into periods of play, for example. So football might have halves. Basketball and ice hockey have quarters or periods. Baseball and cricket have innings. But we're going to use the generic term period in our model. So each period of play is normally scheduled to last for a certain amount of time. For some sports, and again, basketball is a good example, the length of the period is fixed. But in others, such as football, period might extend into injury time or whenever the referee signals the end of play. We also need to consider additional periods of play that are added while the event is in progress, like extra time or overtime. There are some cases here where the length of play might even be truncated. For example, golden goals in football, where the clock stops as a result of action in the game itself. Now, while some sports have clocks that continue to tick throughout stoppages in play, again, football, others have clocks which stop and restart for a whole bunch of reasons, and American sports seem to do this a lot. And finally, of course, clocks can count up or down. Now, I've got a proposal here for a JSON definition that describes the state of the game clock at any point in time. You can divide the properties into different categories. Those that describe the type of clock and the initial state, which are supplied before the event starts and which I've highlighted in bold. And those which are created and used once the event is in progress, which are those that are in grey. So let's have a look at the initial parameters first. Okay, so to start with, each event has a scheduled start time. Now, note that this isn't the actual start time. That would be controlled by the event official, and it's likely to be slightly different. But it's a useful thing to have for display on the client side. Next parameter is the direction in which the clock will count. Okay, so remember, football counts up, basketball counts down. It's an implementation detail which we've not got into yet, but since our clocks are going to be tracking elapsed time, it's really an instruction to the client that modifies how it calculates the display time. But the main part of the definition is how we describe each period of the event. I've created an array here of period definitions where we give each period a user-friendly name, which again is something that we can pass on to the client for display. We also give a duration for the period. So in football, this is 45 minutes or 2,700 seconds. However, since in a football match, each half continues until the referee blows his whistle, we set this auto stop parameter to false. In basketball, you've got a quarter of, say, 15 minutes, but auto stop is set to true. So whenever basketball quarter finishes or gets down to 0, that's it. It doesn't keep going. The next two parameters here, start time and elapsed time, they're both used at runtime. Don't need to set those in advance. But I will talk about what they're used for a little bit later. So when a period starts, we're going to set the start time value. So if it's the first period of the game, that also equates to the actual start time, which is why we didn't need to specify it alongside the scheduled start time parameter for the event. The period's elapsed time is really the value that everything revolves around. This is the time on the game clock at the last state change. So for example, when the half kicks off or when there's a game timeout, that's when that value gets changed. So importantly, we're not constantly updating this value for every tick of the clock. If we're going to do that, it would cause a topic update to be sent out by Diffusion, and we'd just be back to square one. So we repeat this for each game period, second half, third quarter, and so on. We could also include definitions for extra time periods, although they might not be used. But because we're putting the definitions into Diffusion topics, we can actually change the event information on the fly, add extra time on demand if we wanted to, for example. Next four parameters we've got here, also used at runtime. Again, don't need to provide them in advance. But actual stop time is the counterpart to the scheduled start time, only set when the event is known to have finished. Running should be kind of obvious, I hope. It says whether the clock is ticking or not. So generally speaking, when this toggles its state, we'll be sending a message out to the client. Last update time gives us a timestamp for when something happened on the clock. Example, when it changed from running to not running, stopped to started. And the active period tells us which period we're in, or which half or which quarter, which innings, whatever it's going to be. And it's an index into that period structure, so we know which period we're focused on right now. Okay, so that's a little bit of the details of how to do the modeling. So I'd like to jump into the demo now. So I'll just switch my screen. So what I've got here is I've got three displays. The big sort of grey white display is what I'd call my control screen. Now this would really be programmatic most likely, but doing stuff programmatically for a demonstration that really doesn't show you what's going on. So I've got some controls on here so I can manually do things to clocks. And on the right hand side, I've got clocks which represent those events that you can see on the left hand side. And there's slightly different representations depending on the sport. So for example, I could go up to my basketball clock and I'll click start. And what we'll see is that starts counting down. So I've only sent one message at the moment to the client, which is start clock. And it's ticking away nicely. I do the same on football, have those ticking away. Again, one message, there you go, start your clock. And no per second ticks going out. Again, I'll do it for the other one as well. But all of this is really dynamic. If I wanted to override the time, for example, let's move, let's say that there's been an error in the clock somewhere and I want to say, yes, this basketball clock is actually at 11 minutes and 45 seconds. It's only got 15 seconds to go. I can set that time and it sends a message out. The clocks are being synchronized on the client side with just a single message. And that should count down to 0 and it should just stop. because I've said basketball clocks automatically stop at the end. If I was to take a football clock, 45 minutes, let's say, let's put it up to 44:50, set the time. See, that one will go, but it will just keep going until the referee blows the whistle and then someone says, oh, okay, I'm pitch side, I'm going to press the stop clock button. So see, that one's still going, but I can stop the clock. Okay. Now I can also say, go to the next period. So I'll go back to the basketball match and say, okay, next period. Okay, it's got another message to say I've moved on to the next one. I'm on the second quarter. I'm going to start that clock. Okay, just one message and it gets going. I can also, of course, just pause the clock. Okay, timeout in basketball. Everyone's in a huddle. Okay, decided the next play, start the clock again, and it continues. So very, very easy to control. It's all working off that one model. So hopefully you've got an idea that this stuff does actually work. So I'll talk a little bit more about the implementation of it. So I'm going to provide the flowcharts for this. I'm actually providing the source code as well, so you can read through it, see how it all works. But because we're only working with state changes on a clock, we actually have to track those ticks ourselves. So it's actually simple enough. When the clock's running, we have a timer thread which increments a counter and updates the display every second. Easy as that. And of course, if you want to, you could change the granularity of the updates because you're counting the ticks. So if you need something like tenths of a second for a shot clock, you can do that quite easily. And any time that the client receives a new message from Diffusion for that clock, we can do a resynchronization of our local perception of time with that which is on the server. Now, one problem that you might have already foreseen here is that when a new client comes along and it subscribes to an event clock, the message that we already have, that model, doesn't explicitly tell you what the current time is on the game clock. However, we do have enough information to calculate this quite easily, as you can see here. So if the clock's already running, there's a little calculation that you can do. Now, I've got UTC in here as well, because the clock on the server and the clock on the client might be in different time zones. So it's important to make sure you do your calculations based off the same time zone. If the clock's not running and you've received a message from Diffusion, then that's fine. You've just got the elapsed time. It's already sent it to you. You don't need to do any calculation at all. Again, I've got some more diagrams here that tell you basically how to start a clock. And starting clock is easy. There's a little bit of checking at the start to see whether you've actually started or not, to initialize some of those runtime parameters. You set your clock running to true, and then you start a timer. Okay, so the timer is just saying, okay, another little check there, just in case someone's called your start timer call too often. And then it just spins off a little thread using set interval in JavaScript for the client side, and it just increments ticks. And if you've got to the end of the period, you can stop the clock yourself. So one other thing is I'm making the source code for that demo available. It's available at that site at the moment. Now that site, that URL might change to a more official Push Technology site. And if that does happen, I'll make sure that there's a README on there that redirects you. The two JavaScript functions in there that are of most interest are going to be the one for controlling and one for display. So that display one handles football, handles basketball, and I'm sure very easy to modify to handle any other sport that you might want to think of. So the code there is I hope, is easy enough to read, commented, and you should be able to follow through with it. So that is mostly all I have to say about the clocks. Hopefully it's all quite straightforward and understandable. I'd just like to open up for any questions that you might have. If you want to ask questions later, or if you want to get into more detail, then my email address is on there as well. Feel free to send me a message. The recording will be available online shortly afterwards, I guess tomorrow. If there are no questions, then I'd like to thank everybody for your time. Okay, and thank you.